Good evening, everybody. My name is Paul Appleby, as Eugene said, one of the co-founders of Graphify, along with my colleague Ravinder Singh, who is lucky enough to be in Vienna at Semantics Conference at the moment. So that's nice. As Eugene said, we provide products and expertise around knowledge graphs, and Graphology and Easy Graph are our two products. This is not a demonstration at all tonight. We will mention the products where it's kind of applicable, but this talk is really about a process as much as anything for building a knowledge graph. So we do have a mission statement as a company, and it's essentially to make using knowledge graphs, semantics, and structured authoring, which is a big part of our past as well, easy and affordable. And those are two key parts to it, and one of the reasons really we started the company, that those two things weren't necessarily true or aren't always true, and the easier and more affordable we can make this stuff, the better. So you want to build a knowledge graph, where do you start? Many of the companies that we talk to, big or small, are still working with siloed data, especially still spreadsheets or relational databases. There's definitely a surge in the understanding that it can and should be done in a better way, and that managing this data better will increase business value from that data, and that's really the key. So getting insights from that data, that's really what it's all about. Getting the green light for that is not necessarily always easy. Even basic costs for taxonomy management can be challenging, but reducing those two barriers to getting started, as I say, that's really the key part of all of this. And this, as I say, is our mission. So really the goal is to get people from the left of the screen to the right of the screen, where they're creating a rich tapestry of information, a knowledge graph that can be accessed by applications and APIs and other systems. So when we think of a knowledge graph, we really think of it as four key constituents. There are ontologies, taxonomies, what we would call instance data, and then the ability to perform inference or reasoning on that data. And obviously ontologies can model a business need. The taxonomies provide organization of certain aspects of our knowledge. And really instance data is the rest of our data. That could be product data, or it could be rights data. It could be anything that you want to put into your graph, really. And we frequently get asked questions about when the data should be managed as taxonomies and when it should be managed as instance data, so just part of the graph. And just on that point, really, it's very much a case-by-case answer. Questions you need to ask yourself: is the data finite, or is it essentially unbounded? If it's finite, then it may be a candidate for a taxonomy. What's the rate of change of the data? If it's rapid, it's probably not suitable for a taxonomy. And then there are questions around who creates the data, who manages it, what's the governance process, and if it's an automated system, then obviously that's probably not going to be a taxonomy either. So if our goal is to create this rich knowledge graph, where do we start and how do we get there? And one possible route, one journey to create that knowledge graph is as we see on screen. So this route starts with getting us off and running with as little effort as possible, and over time we increase the complexity of the system. And that's the most fundamental part of any knowledge graph system. When we're talking about knowledge graphs, we're really talking about in the RDF world here. We're not talking about property graphs, although obviously they could be included in the knowledge graph space to some degree. In an RDF world, really this is identifiers, and that means IRIs or URIs, and I may accidentally slip between using either of those terms, but essentially IRIs and URIs, same thing. And this gives us two vital capabilities: the ability to identify something uniquely globally, and the ability to connect those things together using those IRIs as reference points. And simply having unique identifiers, or IRIs, is a huge benefit. It can be very difficult to get other parts of the business to adopt URIs as an identifier. So that is quite often your first struggle. I've definitely hit that problem myself. And following on from having identifiers, we can then start to organize some of our information. and that's using taxonomies. And this starts to create common organizational knowledge, and it gives us the additional benefit of being able to connect some of that knowledge together using basic relationships. And even at this point, for certain organizations who are multi-language, then that helps with managing that information as well. And then by moving to the next step, what we call qualified information, or targeted information, we can focus certain parts of our taxonomies at particular groups. For instance, certain knowledge or terms may only be applicable to certain geographies or to business units, or both of those things. For instance, different business units may use different terms for the same business concept. And for organizations with many existing controlled lists and different units, this can also help to integrate terminology by mapping data. And furthermore, we may need to target parts of our information in different senses, and that could be temporal, in that certain terms may change over time. And then beyond that, we can move on to modeling a domain in detail. So taxonomy is obviously powerful, but they're still limited in their ability to specify how things are connected, what those things are, and the ability to add information. So that's really where we need our model. And then finally, as part of this journey, we can have all of our information and models, and we can start to get additional insights through being able to ask sophisticated questions and automating new knowledge through inference and reasoning and insights on that data. So that's the journey in terms of a kind of a process. What does that mean in terms of technology and standards? Well, as we move from left to right on a journey, for identifiers, really, we have RDF, and they're kind of, IRIs are synonymous in that respect. And then we move on, obviously, to SKOS as a standard for taxonomies, to SKOS itself for the qualified information, and to OWL for domain modeling, and then into query and reasoning. And that's obviously dependent on the system that you're working on. And all of these standards have been around for a considerable amount of time, although from our experience, the level of awareness varies considerably from area to area. And to some people, ontologies now can sound scary, but I think the thing to remember, certainly at this point, is that you don't need to use all of it. You just need to take and cherry pick the bits that are useful to you. And really, it should be the job of some software that you're using to help hide some of this complexity anyway. So does all the tooling exist for our journey? Well, the answer is yes. And there are various commercial offerings that cover the whole spectrum. And in a basic manner, we can map it into three areas: taxonomy management, ontology management, and then the delivery and APIs for our knowledge graph platform. And although there is some overlap certainly with our products, you can see that essentially it breaks down into this kind of pattern, where we've got graphology doing the left-hand side and EasyGraph doing the right-hand side, and other systems will do similar things. So the question is, obviously, can you build this tooling yourself? And of course you can. And we've had many conversations over the years about in-house taxonomy management systems, platforms, and really how to deliver a knowledge graph. And the question is it worth it? And we'll discuss that a bit more later on. So how do the components we've just seen really connect together in actually deploying a solution? Well, this is a very simplified diagram that we have. It shows the key kind of components that you need. So we have a dedicated system for managing taxonomies and ontologies, and really the reason we would say for that is that it very much needs a dedicated user experience. And then obviously you have the separate system for delivery of the graph, which may have its own management UI, but essentially it's there as a kind of system to drive other things. And at the bottom, well, there's probably other inbound data sources you'll want to put in your knowledge graph. It may be products, it may be rights information, it could be anything really. And that information may already be in RDF, or it might need to be mapped into one or more of the models. And those models themselves may come from the ontology management system. And then there's the question of, is the system read or read and write? Because obviously, if you want to build an application, It may be a read-based application, but you also may want to add information into your graph. So the key point of this diagram really is the orange box. This is the web application that does the interesting stuff in our kind of mind. The rest of the components on here are really what we would say commodity parts of a knowledge graph or knowledge graph system. So what do we see people doing? Obviously, we provide this software, so we get to see the problems that people come to us as potential customers with, and also as people progress along their journey, when they become customers, how they move through it and a kind of level of sophistication. And to me, one of the most amazing things I think is that there is a wide variety in what stage different companies are at, whether they're big or small. And in many companies, it's just a single person that's doing this work to try and get it off the ground. And that might involve building a team, procuring software, and doing evangelizing as well, which is obviously an important part of this process. And then there are also budget concerns as well, which don't go away just because you're necessarily a big company. There's quite often an expectation of a very big upfront investment to get a knowledge graph platform up and running. But like I said at the start, most common situation is that people start with a bit of information on a spreadsheet and an awareness that there is a better way. So what are a few examples of what we see happening when people kind of start this journey, and maybe how do they move along, and what suggestions do we make to help them to move forward? One situation that we see, and it's quite common, is that people have a single taxonomy, a legacy taxonomy, and a single, and sometimes it's a monolithic thing with everything thrown in it. And really, it's common for this to be managed, in a spreadsheet or in a kind of quick and dirty homegrown taxonomy application. And in situations like this, one of the first goals really is to sometimes pick that taxonomy apart. And there's an education process into how that can be done, and how in software that is enabled to do things like manage multiple taxonomies and so on. There's a better way to do it. You can break it apart. And you can let it be governed and managed and connected in a better way. And that's really, so one of the big first steps that a lot of people actually go through. And then it's obviously not uncommon for a single person to be in control of this process, but there is also a desire to make collaboration easier. And that's very difficult to do, obviously, if you're on a spreadsheet or in a file. So a commercial system that provides collaboration capabilities is definitely one of the big reasons why people are looking to do this kind of thing. And we can kind of show them how you can work better as a team. And then as people start on their sort of knowledge graph journey, they do still need to keep the information integrated into their systems. And again, the way that's done in legacy systems, quite often it's via spreadsheet or a CSV file or something. So it's quite important to show people that if you onboard into a system like ours, you can still get data out in things like spreadsheets, and so easily integrate it back into the existing systems as the first step of a kind of migration, while teams maybe evolve to direct API access. But we certainly shouldn't underestimate that for getting data in and out, it's still an absolutely critical part of the system. Not everybody's ready to suddenly just jump on and start grabbing RDF out of the system from day one. And then another desire really is obviously to connect the information together better. You can't really do that in things like a spreadsheet. People have this information and they know they can do more things with it and they can enrich it. So to expand on the final point from the previous slide a little more, as users start to build out their knowledge graph, they will ultimately arrive at ontologies. It can take different lengths of time depending on kind of the use case. And it can, as we said, certainly be a slightly scary experience, especially because there's so much material on ontologies and OWL, and a lot of it's very academic, a lot of it is very difficult to read or to learn. So really learning even the basics of OWL can still be quite confusing. We are very much in the camp that a little bit of ontology takes you a very long way. And so the question is really which bits of ontologies and OWL are people using, or what do they need to progress and get going on that journey? And there are a few things that we see. Class hierarchies are absolutely the first thing that most people will tackle in this process. They're really the easiest bit, I think, for people to understand, and they get widely used early on. And it fits nicely quite often with the idea of breaking those monolithic taxonomies apart, managing them in multiple taxonomies, especially where things like faceted taxonomies, where, for example, you might have a taxonomy of colors, and each concept in that taxonomy may be given a class of color from your ontology. So there's a nice easy path, I think, for people to start adopting classes and enriching their taxonomies in that respect. And that can give a lot of value in things like querying just by doing that. Then you get some slightly more advanced ontology features such as domain and range, which are still quite commonly used. But this is certainly an area where a lot of care is needed. Not to confuse inference with constraints. And obviously OWL is really all about making inferences, where a lot of people think about data as constraining what properties can go on, what classes, and that kind of thing. So it has to be done with care, and we're always keen to help people do that in the correct way. And also to help users here, there's another standard, shackle, which is about doing constraints. It's a W3 standard as well, and it's a constraint language. And what shackle shapes let you do is define sets of properties and relate them to things like classes. Within graphology, we actually call these property templates, and these templates are generally what the user is intending to use. So I think we've got an example on screen here, which shows a template in graphology, which is designed to be used on a concept of a class of airport. And you can see we've selected various properties from our ontology, and they will appear on concepts with that class. So it gives you a fine-grained control over being able to show those properties and obviously then enrich them. And that's what most of our users are doing as they move on to start using ontologies with their taxonomies. But when creating models, it's important to work out what goes in the model, what should be taxonomies, and what should be instance data, what's the rest of the data. We're always keen on keeping the model as simple as possible, and using taxonomies well can play an important part in doing so. And I've included a graphic from a recent talk by somebody called Katarina Kari, who works for IKEA, and her talk is based on another talk by Dave McCoon, and it's very good and shows really a different way of thinking about it potentially from how others might think about throwing everything into an ontology. It breaks it down into 3 layers, and that's definitely worth reading up on. So a quick aside, we said what people are doing. There's some interesting aspects as to what people don't do, or don't do very much. Knowledge of SKOS Excel, which is again another W3 standard, the extension to SKOS for labels. Knowledge of it is very limited, and I think this is a shame really, because for certain use cases it's a very good solution. We can see an example here relating to airports, for instance, where the name has changed over time, and this kind of temporal labeling, like we mentioned earlier, is a perfect example of where something like SKOS Excel can be useful. And even SKOS collections, again, are very limited in their use, but again, they have real world uses. A great example for ordered collections, which can allow users to create sets of concepts from multiple taxonomies and order them as they want to present them. And that isn't necessarily the natural alphanumeric ordering. So if you want to display in a different order on your website, ordered collections are a great way to do that. But these are definitely underused features that can form part of your taxonomy ontology management, and obviously then be fed into your knowledge graph to drive end user queries and applications. So we've talked about what users are doing. but where is the demand? What are people asking for? How are they trying to stretch the system, and essentially what we can already provide. So there are certain things we're seeing from users as they progress further along their knowledge graph journey. Absolutely key for most, and the most common discussion point is collaboration. Although some organizations may be starting with a single person, as they expand their teams, those teams need to be able to work together easily. And modern systems elsewhere allow people to do these kind of things. So there's no reason why in the knowledge graph space that shouldn't also be true. So examples are SMEs, subject matter experts, potentially making suggestions for taxonomies, for instance, or a team of taxonomists working on a large taxonomy at the same time, which is not uncommon on a large taxonomy. Or there's maybe domain-based teams who are tasked with working on their own specific taxonomies in their own domains, but may need to connect to taxonomies in other teams' projects. And all of those are key collaboration features, and we support, Graphology supports all of these ways of working. And Graphology actually updates things in real time, so there's no delay. And these are, again, features that are expected, and these are what people want. And we continue to expand collaboration capabilities because people keep asking for more and more in this aspect. And then we have the SKOS standard, and that defines certain integrity checks. The most common one, I think, is that only one preferred label in any language can be on a concept. And again, as most commercial systems would do, and in fact most systems, they would implement these SKOS integrity checks. But we're seeing increasing demand from users to implement additional checks, implement their own business rules. And these can be from very simple examples, such as a label should have a maximum length, for instance, to help with display on websites, or there should be consistency in the use of case. And then you get slightly more complex ones, or slightly odd ones, where we've been asked that somebody wanted to say they must always have at least one alternative label. So it's crucial to be able to report on the data and allow users to create what are essentially custom reports. Now, luckily, in the semantic world, we have Sparkle, and that allows you to query the data in pretty much any way you like. And within Graphology, custom reports are indeed based on Sparkle queries. Now, I hear everyone shouting, yes, that means somebody needs to know Sparkle, and there is certainly a learning curve to it. I don't think it's quite as difficult as some people make it out to be, and you can do some very good stuff quite quickly. But it's all done within the UI in Graphology, and once written, these queries are available to users in the dashboard. They don't need to go anywhere near a bit of Sparkle, and we're always happy to help customers with some Sparkle. As I say, that Sparkle gives you complete flexibility to really generate whatever information you need about your data. And in terms of this shackle, also plays an increasing role, and because it is constrained, so obviously you can also constrain certain aspects within the system as well. And we'll be expanding our shackle capabilities even further in the near future. There's quite a bit of demand that we're seeing for that. Another aspect that's becoming more and more of a must-have is versioning of the ontologies and taxonomies. So as people start to build out their graphs, many use cases, they need to query data or at a particular version, or at least be able to go back and see what the data was at a particular version, maybe do a delta to see what's changed. And although we provide an audit trail of changes, again, you can use Sparkle to do your own kind of queries across those versions. There is a question over where these versions live, potentially. Is it within the taxonomy management system? Is it within the wider knowledge graph? Or potentially it's both. And I think to some degree, the use cases, again, and how you want to query it will dictate the right approach in that respect. But it's certainly something that people are expecting now to be available. But probably the most interesting point, or the most interesting thing that we are seeing recently, is a big upsurge in demand for better tools for managing ontologies. So we definitely see a split in sort of uses between what we would loosely call casual ontologists to those who are maybe full-time professional ontologists. But demand is coming from both regions, as we see it, or both directions. As casual ontologists become more confident, they want to use more ontology capabilities, whilst many full-time ontologists want ontology software with the full set and full range of enterprise features that you might expect, with with good UX, with an easier learning curve than maybe something like Protégé has to offer. For many of us, it's easy to get lost in the technology. It's always good fun to play with the latest shiny toy. And I think in the area of semantics, the shiny toys are Shackle and RDF Star. It's quite common when we have early conversations with potential customers for a lot of technology to be mentioned. We get asked the kind of thing, do you support technology X? And sometimes we do, and sometimes we don't, or not yet maybe. I think the problem with this scenario or this situation is that often the questions are asked not within really the context of the use case or any particular use case. So we always try to direct the conversation back to the use case that and to the problem that people are coming to us and trying to solve. More often than not, these buzzwords, they're not relevant, or they're not so important at the start of the journey. And sometimes a different, simpler approach or an existing approach is more suitable. So I think one of the key points we would always make is, as you build out your knowledge graph, stay focused on the problem you're trying to solve. Don't get bedded down, stuck in the technology and all the shiny stuff. And then we get on to build versus buy, which we'll always get asked in these situations. And often the conversation goes in different ways, depending on who is tasked with initiating the conversation. Sometimes we get contacted from a taxonomist or an ontologist. Sometimes it will come from a technical team. If it's coming from the technical team, not surprisingly, maybe they're more confident with a proposed build solution. But it's still rare that the necessary skills, the semantic skills, are in-house already to build that software. And sometimes it's not so easy really to assess commercial or open source offerings, again, because the skills aren't there to do that. So there's definitely that initial problem to get over. So in terms of making a decision, what are some of the points to consider? And there's quite a lot of wording. I'm not going to spend too long on this, but it's there if somebody wants to take a look after. And really, skills are probably the most important. As I say, they're still in short supply. And it's not just the initial build phase that you need to consider, ongoing enhancements, maintenance, and really critical is keeping those people on board and interested. A lot of projects will fade or fail ultimately once an initial team leave for new pastures. I've seen it, I've been part of that in the past. So it's really critical to think about the long term, not just the initial build of the system. And then there is time. Do you have time to build out your software? So to give you an idea, for graphology, so we started over 3 years ago now. It took 18 months to get graphology to what we considered an MVP that was commercially viable from a feature perspective. So it had to have enough features that we thought people might actually pay for it. And 18 months later, we're still releasing almost monthly and regularly adding new features as users give us feedback. And as we saw on the other slide, pushing where they want to go, and that's great. That helps us. So it's not an inconsiderable task to build these systems from the ground up. Standards is an interesting one, and it's rare that we see in-house systems that use standards, certainly on the taxonomy side and the use of SKOs. And of course, that may be fine. It could be an really old system that predates the standards. But once you start to also integrate your data into the wider organization, that integration and those standards become more important. And obviously most commercial systems are built around the standards. So you have a head start on the commercial side, generally in that respect. And many companies really are only working with small scale data. on the taxonomy and ontology side. When you actually think about it, you need an awful lot of concepts to get anywhere near, say, 1 million triples. You know, thousands and thousands and thousands of concepts. And this, we suspect, is probably why in the past, at least, it's been hard to justify a big spend on taxonomy management software to manage what is essentially a small amount of data, and possibly why things like spreadsheets are still common or in-house management systems get built. But you probably don't need an expensive system to start with. You know, you don't need an expensive taxonomy management system or an expensive triple store to back that up to get going. You know, especially when that's on top of maybe you know, the taxonomy license as well. And that was one of our goals as a company, was to kind of expand and make that route easier and more affordable, as I mentioned at the start. So we offer SaaS for graphology and a range of subscriptions. So you can start very, very cheaply and very small, but grow as you need to. And ultimately, you might get to those expensive commercial solutions in the end. Really, scale in a knowledge graph will only come when you start to add instance data. And that, you know, that scale and the delivery of it, that needs appropriate architecting. So the question there is, if you do build and you want to deliver your graph, do you have the skills again and the time to build out not only maybe the taxonomy and ontology management, but the delivery of the platform, or one or other of these? And then, as we mentioned, things like collaboration are in high demand. And this will probably be the case even if you build it yourself. Your users are going to expect these kind of features. So are you ready and prepared to add all those features? And then obviously support is critical. And do you have all the IT set up to manage all of this as well? And without doubt, cost is critical, and it can be very expensive to buy some commercial systems. I'll say other commercial systems maybe there. But if, you know, building yourself, there are also potentially many costs, and they're not always that obvious at the start. You've got design, and that's architecture and things like UX. You've got development, QA, the IT infrastructure costs, support, security, all of those things. And then your customers or your users, even if they're internal, are still going to expect certain SLAs or levels of SLA that you need to you know, meet. So just to give a kind of an example of how the build versus buy might compare. A year's subscription to graphology, as an enterprise subscription for a typical company, can cost less than hiring a contract developer for 2 weeks, and there are no other costs. You get support, all of those things. So hopefully you can see that maybe a buy is a bargain compared to build, but obviously every situation will be different. Security is always a key consideration for most commercial systems. As I say, we offer SaaS. We also offer a managed service as well out of the box, because basically of security. And these two different offerings will give different answers to security teams' questions. But I personally think there's an interesting question over the sensitivity of things like taxonomies and the data in them. Personal information is rare in a taxonomy, and on our SaaS offering, our T's and C's do not actually permit personal data. So there's really quite often a question over the commercial sensitivity of taxonomies and what level of security is applicable. And we've certainly had customers where the security team, they started with no way. But then with a bit of explanation from us and the taxonomist, those security concerns fell away. It's definitely an interesting area. I think it's worth a debate in its own right, in my mind. And then you get things like UX, and that's always an interesting one, and quite often on in-house systems, that's a forgotten part of the process. But it's not just about UX for on screen, it's about the user experience for developers too. We have found with hard experience, there's no point giving them things like Turtle or APIs that work with OWL. They need technology that they're happy to work with, things like JSON and GraphQL. And so obviously we get to the question of open source, because that's obviously a kind of a midway option. But it's rare actually that we hear potential customers considering it as an option. And I think that's probably because it's not always free when you consider other costs. Often there is a lack of enterprise features, and enhancements and modifications can be really difficult to get done. And then again, the UX is generally poor compared to most commercial systems. And as we mentioned earlier, In the ontology space, we're seeing demand for software that isn't Protégé. So just to summarize on build versus buy. Yes, you can build it. Our question, obviously, we may be slightly biased, would be why would you want to? I think the critical part is building the plumbing generally doesn't add any business value in this case and can take a long time to do it at large cost. Most of the time, the plumbing is the same. We have built the same thing several times in our over the years. And the reason this plumbing is generally the same is because the real point of a knowledge graph is it becomes a data-centric approach, and it's the models that are driving everything. And that's really critical, when you think about a knowledge graph. So really, the value comes from building the application on top of your kind of platform, not the actual platform itself. So that's kind of a process. How do you actually go about setting up your knowledge graph? So we've seen that from an information perspective, we can add increasing complexity and sophistication. And really step one, though, is simply to deploy your taxonomies. And I say this is just one, this is only one route, but we feel it's a great route to get going. Don't feel your graph has to have incredible complexity and hundreds of millions of triples from day one to be of any value. If your graph is nothing more than a single taxonomy, maybe a taxonomy of languages or something like that, and that provides real business value, that is a win. And it helps with the evangelizing, and it helps, to move along that road, that journey. And the first step for many may be to feed those taxonomies into existing systems, so that the management of, is moving into that centralized place. That would do things like maybe enhanced search and so on, query expansion, broad and narrow relationships. But to get real value from a graph solution, an appropriate system is needed, not an existing system. And that needs to provide certain features for managing the data and exposing APIs. We, as I mentioned at the top, we have a solution called EasyGraph, which is our offering in this space. And it allows automatic API generation from a model. So it's got a no-code approach. And again, that's something that people really like in this space. And so you can start with something as simple as the SKOS model. And that means you can expose a taxonomy API and be up and running in literally minutes. And then if you expose your taxonomies through your API, that starts to let other systems use the API, begin a process of adoption of those taxonomies, and of course, the adoption of unique identifiers, which again is critical. And then you can get to things like moving on and using SKOS Excel and all of that kind of capability. And depending on the scale of the graph and the uses of the graph, that aspect again will be important, and it needs to be able to scale. But that scale can come over time. And so again, EasyGraph can start with open source, and it can work with numerous backend options. So you can scale from free open source up to large scale commercial as and when the demand is there. You don't again have to do that from day one. And then obviously when you've reached the ontology phase of sophistication, you incorporate that into your knowledge graph deployment. And again, you can generate additional APIs from that. It can be a read-write graph. They're not, it depends on the use case. Some will be read-only, some will be read and write. And so in this instance, again, Shackle is part of the system, again, automatically generated from the models. And it manages the right part of the data, and that can be really crucial, obviously, for getting data in the correct way into your wider graph. So in this aspect, then really you simply need to create the UI for your domain. And although there are systems that automatically generate UIs from models, we find they quickly hit limits. Really, if you're going to spend money and time anywhere on a knowledge graph platform, we would say spend it on the user experience and that secret sauce, because that's what people encounter. They're not going to care what's going on behind the scenes. And so making that UX easy for developers as well. So giving them things like JSON or JSON LD maybe, and GraphQL, that's the kind of stuff they want to work with, not hardcore semantic technologies. The rest is really just behind the scenes is generic plumbing. And then really the final part of deploying the graph is incorporating other data sources, as we showed at the diagram at the top. And that can be done physically by transferring the data, but more commonly now, It's done through virtual means, and some of this quite often happens at the database layer, that kind of virtualization. And the model for those data sources may also be managed in your ontology system and fed into the graph. And then obviously longer term, you can even do stuff like NLP to automatically generate parts of your graph. So a few patterns of working that we see. So many organizations, as we said, still have a single taxonomist, and there's an incredible burden on this person really to push things forward. We increasingly see a desire for taxonomists to engage with SMEs directly in the taxonomy management system. So they want that collaboration capabilities, and the tooling needs to provide that. And for advanced organizations, they're actually, we've got some customers that are working with multiple taxonomists and ontologists using the full capabilities of our software. And really, the key driver is context. They're doing complex stuff at the end, and the power of those relationships and the classes and all of that stuff is driving these processes, quite often machine learning processes that building AI solutions. And we're starting to increasingly see teams working independently. I think as more and more of the knowledge is being used and put into the graph, these teams are being split up and working independently, but connecting together. And obviously, most importantly, we're seeing an increase in understanding at the C-level and executives that all of this stuff is good stuff and can help solve real business problems. And then a few final observations. And some of these, it's very interesting. There is definitely a lack of knowledge of the standards in all of this space. And surprisingly, it's not uncommon that experienced taxonomists have not heard of SKOS, even though it's been around since 2009. It's one of our first questions we ask in a demonstration or a meeting is, what's the level of understanding of things like SKOS? And quite often it's very low or non-existent. And as I said earlier, understanding of SKOS XL is also very limited. And there's absolutely better scope to communicate the benefits of those use cases it can solve. There's always a question over the use of what we call instance data and whether or not something should be managed as a taxonomy or not. And again, on a case-by-case basis, that's the way to answer that question really correctly. And there's also confusion between whether to use taxonomies or ontologies and sometimes how they interact. And I'm going to have a little dig at some that there are other tooling out there that we think sometimes causes a bit of confusion by being very loose with terminology. Sometimes everything is called an ontology, and that's not actually the case under the covenant. So people get confused when they see the actual data. And many ontologies that we see should or could, be better managed as taxonomies using the SKOS model. And another thing that we see, which definitely causes problems, is we see signs of over modeling, and that's modeling in ontologies. We would always promote using minimal semantics to get going. Meet those initial use cases, worry about expanding the model later when you need to do that. And we've unfortunately seen cases where people have tried to adopt this technology and then have failed simply because they've got bogged down on the modeling side of things because they've just gone too far too soon. And there's definitely confusion around reasoning and constraints, and that's mainly from people again who don't quite understand how to the right level and come with maybe an object-oriented background and are more used to things like constraints. So in summary, start small, even if you've just got identifiers. That's a great benefit. Absolutely fundamental to a knowledge graph are taxonomies. So if you start there and do nothing more initially, that's great. But create those taxonomies using standards, and in some kind of taxonomy management system, so you've got that kind of easy way to manage them, and then expose those taxonomies if you can, and start to get them adopted. Even simple adoption can have great benefits, things like content tagging, search, and so on. Don't spend a fortune to start necessarily. Get going. You can always expand and increase what you need later on. And obviously, then think about using ontologies and start to model your domain. And again, expose those, like we said, via the APIs. And connect everything together, your taxonomies, and use your ontologies to do that, and integrate other sources into your graph. And then build those applications on top. They're the secret sauce. But the final thought really is, most of all, focus your efforts on the bits that really add value, on the use cases and the problems you're trying to solve, and don't get distracted by all of this technology and all of these standards. Focus on solving that problem. And on the last slide, yes, if you want to try some of this stuff out, there are free trials you can use for Graphology and EasyGraph. Thank you.